Good morning to all. Now, this is in continuation with the previous series on problems on Fourier series. Let us continue. Actually, we solved, once waveforms are given, we solved them for Fourier series. Now, one important point is that, for example, in the first case, just look at, in the first case, what did we make it? Just we drawn a waveform like the sawtooth waveform. Sawtooth waveform. It is a sawtooth waveform. Just observe the following figure. This is 0, t, 2t, 3t like this. Now observe this one. This is x of t. This is t time. Now just look at here, amplitude is A. Here also amplitude is equal to A. These two waveforms are same. Students should concentrate on this point. This is sawtooth waveform. This also called sawtooth waveform. Now just look at, these two are same. These two are same. How can you come to this one? How you can come to this one? These lines are mandatory lines, waveforms. For example, look at, for our understanding, look at same periods are given, 0 to 2, 3t, 3t, like this. If you make a connectivity line like this, just look at connectivity of these. Now just look at, are these two not same? Yes, these two are same. Whether it is a sawtooth wave. This is a sawtooth wave format. Whether it is given in this format or in this format, both are same. Both are same. Students have to observe this one. One important point. Another one. Now just look at sawtooth waveform. Now, we did another one. What is another problem we did? Just look at. Now just look at this problem we just solved. X of t, this is a, this is minus a, this is minus t, 0 or minus t by 2, 0, t by 2, or this is 3t by 2, this is 2t, like this. Just we solved this problem. Look at, here also amplitude A, here also amplitude minus A. Here the point minus t by 2, 0, the point t by 2. Here t by 2, the period is t by 2, here it is t, now it is 3t by 2 like this. Okay, this is t by 2, this is t, this is 3t by 2 like that. Now Are these two same or not? Same. Now just look at the main wavelets are like this. If you make the connectivity to this point like this, now just look at continuation. Are these two are not same? These two are same. That means what? Once we are going for solving one problem, indirectly there is another problem. A problem is given in this format, a waveform is given even in this format or in that format, both are same. Both are same. This point is very much important. Just students have to take this into consideration. Now, just we did one problem that is called what? Square waveform. In this format we made it. Understanding? This is 0, t by 2, t, 3t by 2, this is 2t, this is 5t by 2, like this. There is a wavelet format. Problem is given like this. This is amplitude A, this is amplitude A, this is amplitude minus A. Minus A. Now look at, if the same problem can be asked like this, x of t. This is minus here. Here this is 0. Here this point can be t by 2. This point t. This point 3t by 2. This point 2t, like this. These two are same. How and why? Just look at. If you make adding the curve above the time axis t and below the time axis t. Now just look at, all these are dotted lines. Now students have to make concentration on the dotted lines and the thick lines of the graph. Now just look at, all these two are same or not? Square wave format. These two are same. Square wave. These are square waves. These two are same. So students have to take all these things into consideration. The problem can be given even in this way, either in this way or in this way. But in what way they give, these two are same. That thing just you are supposed to make it. Now you can make another one. Suppose a curve is given like this. Find the Fourier series of this. This is A, this is minus A. Or just you can make, in place of you can keep 1 or minus 1. But here this is minus t by 2, 0, this is t. Now here this is 3t by 2, this is 2t, like this, the curve. Find Fourier series of this one. This is the direct representation of which function? The function is, this is a sine graph. Therefore, the function is, the signal is sine t. Sine t is what? Odd. It is odd signal. Odd signal means what? Here a not equal to 0, b not equal to 0, but bn not equal to 0. Sin t is odd, but minus sin t is even. Make it a point. Similarly, you can make it another format. Now like this. Here Another waveform can be given like this. In this way. What is this one? The amplitude equal to 1. This equal to minus 1. Now here this is minus t by 2, 0. This becomes t like that. That is 3t by 2 like extension. What kind of curve is this? This curve, it passes through 1. It passes through the origin. It is sine curve. It passes through not origin. One step ahead, passes through 1. This is called which one? Cos. Therefore, this graph represents, it is cos t. Cos t is called what? Cos t is an even function. For even function, Bn equal to 0. You are supposed to find the values of a0 and an only, for not Bn. For odd, no need to calculate a0, b0. You have to calculate only Bn. So, this ends the session on Fourier series problems. So now in the next session we are taking another concept. Thank you.